Men, and I use the term loosely. It's the middle of January, holidays is over. Call me a curmudgeon if you want, but that's all behind you now. Time to quit fooling around with Christmas trees and presents and all that crapola, and time to get back to work. And by work, I mean it's time to start watching more of these videos. Preferably on your boss's time, not yours. Don't waste your time watching these on your time. Watch them on your boss's time. You got a computer job, tune up YouTube and watch this instead of doing that computer shit. You got a job, ain't in front of a computer, well, get your phone out and, watch as many videos as you can while you're supposed to be working. Videos are much more important than work. Anyway, first job of the year over here. And I'll show you what the owner was concerned about. The owner was concerned about this here. This face of the counter shaft thrust washer where it meets the crankcases was chewed up, and he was worried about that. Apparently he had these cases and parts at his shop, asked them to put it together. They looked at this and said, hey, this is dicked up, we can't do it, and you need to get that fixed. I don't know that you need to get it fixed. I might do something with it because he wants me to. If this was an engine that I had in here, or if it was one of my engines, which I always use, what would I do if it's mine, as kind of the standard, I'm not sure I would do anything with this here. Now, I could lay a bead of weld all the way around this thing, and I could put it in a milling machine, flatten it off, and I could, by running a boring bar in the backwards direction facing the wrong way, I could even out this edge a little bit. I could do all that. If that sounds like a lot of machining and welding time, yeah, you're probably right. I don't know that it's worth it or not. But anyway, that's kind of what the owner wants me to do. I haven't decided whether I'm going to do it or not. I may call him and say, you know what, it just ain't worth fucking with. Let me show you one thing that came out of this that is kind of interesting, though. See this here steel ring? This was embedded in the aluminum around that countershaft thrust face boss. I suppose that damage on there was caused by too small of clearance or no clearance between the countershaft low gear and the crankcase, and whatever thrust washer was in there, of course, got heated up red hot and melted itself. Apparently, a little bit left of it, that was left of it, got melted into the crankcase. Picked this out of there. Interesting. I mean, damn near a perfect circle. Side note. Anyway, the owner sent me a couple pictures, and he was worried about this. Apparently, the other shop was worried about this. I was worried about this. In the picture, which I think I got a copy and I might post for you right now. I was worried about this. This piece was not broken off in the picture. There were two little cracks here and here, however. So when I got this thing, I stuck a screwdriver or something in that hole, and I pried on it a little bit, and this popped right off. This has been broken for a long, long time. You can see this crack. It's dirty, it's gray, it's soaked with oil. This has been cracked on the verge of breaking for a long, long time. Anyway, this is what I was worried about. I'm not even that worried about this, though. There's plenty of meat down in here to support the shaft. Strictly speaking, I don't know that this needs to be fixed. I could put the engine together right now and everything will work fine. And, there's going to be another one of them tricky things. One of the ways to fix this might be to just bore the whole damn thing out, machine another part with the correct diameter, stick the shifter fork shaft into the trapdoor, put your repair piece on the other end of the shaft that goes in here, flip this thing over and weld it from the outside. That might be one way to do it, but that sounds like a lot of work to me. The other way to do it might be to just build this all up with weld and go in from the other side and re-drill it and ream it to the correct size. I think I got a reamer the right size. There's enough left of this hole that won't be affected by the weld, so that I should be able to get the shaft back in there and get her lined up under the center of the mill and effect a nice ream job, drill and ream job on it. I would drill it, a size smaller than the actual hole, and then ream it to the exact size. Like I say, I think I got a reamer. I believe that's a 5/16 shaft. I got to measure it though. But anyway, that's the job before me. And welding these things are problematic. This is my torch. Got the shorty cap on her there. Getting in there and getting the angles you want, it can be difficult. I think I could get around this one without too much great difficulty. This is going to be a little trickier, but I think I could get in there around this and get some good weld beads up on there, I think. Plus, this case is pretty thick in through here. This is probably 3/4 of an inch, 5/8 inch thick aluminum there. My welder goes up to 210. It'll be pegged out trying to get enough heat in there. And people talk about preheating these things and baking the oil out and yada, yada, yada. I think that's all bullshit. You could bake the oil and it'll turn from oil into carbon. Well, carbon is just as bad as oil in there. The real reason I think you preheat these things is to get some heat in there. It's a little chilly here. It's 40 degrees in the shop, and going from 40 degrees to 12 or 1300 degrees in a half a second. That heat is just going to be sucked out of the the weld zone into the rest of the case. Whereas if you got the whole damn thing heated up, it takes a lot less heat off the torch to get your weld started. So generally speaking, the heating part of this is to make it easier to get your arc started. And I think also the heating helps keep, the preheating that is, helps control the warping of the metal. You throw a bunch of heat in there and this damn thing is going to want to expand. It's going to force the case to bend all kinds of ways it wasn't meant to. And you could have, warpage, you could have cracks. So I think definitely, considering the amount of heat I'm going to throw into this thing, we're going to do some preheating on it. But should I decide to accept this job, first thing I need to do is get it degreased. So we're going to go degrease this and I'll be back. Oops, one more thing I was going to talk about. The threads. The threads on the crankcase drain plug are all dicked up. So I'm going to grind this shit all out of there. You got to get the threads out, because at the bottom of the threads is where hides the oil that will contaminate your weld. So I need to get this down to bare clean metal inside there. I'll make a plug of aluminum that goes in there with deep chamfers on it so that I could get penetration, pert near all the way down to the middle. And then I'll weld that in. And then look at fucking Harley. This is 74 case. This is, your middle of your AMF era there. Could they drill the hole in the middle of the boss? No. Let's put it all the way over on one side. So, you don't have good sealing surface over here. How can they expect this to work? Harley, their quality control just fucking sucked for quite a long period of time. So anyway, I think we'll fix this up too. The other hole on the trans isn't bad. We'll leave it alone. But this one we're going to go after. I got her all cleaned up. Time to drill out that sloppy drain plug hole. Now we're going to give her a generous chamfer so the weld has got area to penetrate down into. Flipped around, we're going to chamfer the inside because I'm going to weld it on both sides. I got about, I don't know, 5 minutes making this little plug button. Just going to weld her in that hole, so I use a little less welding rod. This is ready to get preheated, so we're going to throw in the oven and come back in an hour. Got the cases fresh out of the oven. Going to see if I could weld these. I sawed the bristle end off of a stainless steel wire brush, and I'm holding onto it with a small vice grip so I can get straight down into the transmission cavity. The handle on a regular wire brush will get in the way. If the weld area gets contaminated, I go back in with the ball end carbide burr and clean the crud out so I can get a fresh start. Just cleaning a little more schmutz out of the weld zone to get down to bright and shiny metal again. The little spring clamp is holding a piece of metal over the bottom of the oil drain plug hole to keep my little plug button from falling out when I flip the case vertical, which I'm about to do. To put this all in perspective for you, I started the camera when I began welding, and I didn't touch it or move it until I was done welding. I can't mess with the camera while I'm welding. It takes too much concentration to do the welding and fiddle with the camera at the same time. So, of course, when I flip the table vertical to weld the oil drain plug hole in, you can't see anything because it's on the other side of the welding table. So I'm done welding the plug on the outside of the case. Time to flip the table over the other direction, reverse the case so that I could weld the inside of the plug. When I'm welding cases, I always try to weld both sides to make sure I've got good penetration and make sure there's no pinholes through which oil could leak. ran the camera the whole time I was welding. There was an hour of video running, an hour of video recorded. So I was under the hood welding for an hour. Several times I had to stop and grind a little bit and then restart. There are many passes on here, some difficult, tricky angles to work with, but I'm pretty satisfied with that. That looks good. So we're going to go out to the dirty shop and start machining this back to normal. Just FYI, when I got done welding, I threw this back in the oven and let it cool off over a couple of hours to, you know, just even the heat out and let it normalize, so to speak. So we're going to go do some machining on this and hopefully get it finished up in the next couple hours. This is the shifter fork shaft hole that is welded on the inside. This is the shifter fork shaft. I centered the hole the same way I center valve guides when I'm doing the C cutting, just manipulating the table X and Y to get the hole under the center. So that goes nicely in there. This shaft is just a little bit under 3/8, like 0.374 and a half. My reamer and my drill bit are just a little bit over 3/8, like 0.375 and a half. This is a letter drill. This is a letter, I don't know, a letter V drill, and it is just a scotch under 0.375. So I'm going to use this drill to drill out the hole. Let's see what this looks like. And that's all there is to it. As you can see, not a lot of metal came out of there. I was confused as to how that could have been cracked, because unless a sideways load is put on it, there's really no forces that are going to crack that thing. But look at this. It might be hard to tell, but this end of the shaft has been ground as if on a bench grinder, which leads me to wonder whether or not there was a big burr or whether this end of the shaft had gotten dicked up and maybe somebody hammered it into the case and, you know, it mushroomed out a little bit and that caused that part of that boss to break off. Anyway, for what it's worth, that could have been a problem. All right, I'm going to flatten off the inside of the shifter fork shaft boss. I got I don't know, some people call it a spot facer, some people call it counter bore. I got one of those two tools chucked up in the mill. The pilot is, I don't know, 25 or 30 thousandths smaller than the hole in the crankcase because I don't want the pilot chewing up the bore any. So let's give it a try. Looks like everything is going to clear. And that's all that needs. Yeah, that's good enough for that. I may round this edge over a little bit with a Dremel tool or something. And of course, the next thing to go after is the bore for the counter shaft to smooth this over and straighten it out. I got my coaxial indicator touching about halfway down the bore of the counter shaft bearing boss. I've been playing with this to center it up under the mill. And it's probably as close as I'm going to get at 1/1000th of an inch. Play with it a little bit more maybe. I'm making it worse. Come back the other way. All right, I think that's as good as I'm going to get that. And I'm doing this so I could center over that counter shaft bearing bore. And I got a little boring bar here. Then I'm going to run backwards. And I'm going to bore from the outside in instead of the inside out. And I'm going to try to square up the corner of that weldment down there. So I'm going to call this good to go. Going to lock the table down. And I got the mill where I want it. I'm going to center the DRO in case I move it. I know I could just bring it back to 0 and it'll be good. I got a little tiny boring bar I ground. I actually ground it to do clean up exhaust spigots after I got done brazing them, but it's working for this too. Anyway, I'm running the milling machine backwards. I'm boring from the outside of the hole in, and I'm squaring up the outside edge of that weldment that I just put in there. I got the bottom of the hole zeroed, so I'm going to run this down until I zero out, and I'll be at the bottom of the relief for the counter shaft low gear. This is kind of tedious, but anyway, that's what I'm having to do. It took probably an hour just to get this set up, so like I say, we're going to go for it. Running it backwards and running it in instead of out. Most of the time you run a boring bar out to bore a hole, and I'm actually running the boring bar the opposite direction, opposite rotation direction, and in the opposite direction of travel. It's a little tricky. Yep, seems to be working. All right, I'm hand holding the camera to try to show you what was going on here. I ran that boring bar down and I cut this outside edge to clean it up, square it up, and to even it up with the bottom of the case. And there really is no perceptible height difference between this area that was touched with my boring bar and this area that wasn't. I mean, for all intents and purposes, these are exactly the same. And this surface really doesn't matter anyway. This is relief for the face of the gear. The surface that matters is this surface here, and that's the surface I'm going to square up here momentarily. And I think I'm just going to put a mill in there and walk it across a couple of times, and I think that'll do it for this part of this repair. I got a 5/8 inch end mill chucked up in there. You know, one of the challenges of working on these Harley cases like this is if you got a mill down inside there, you need long everything because at least my mill head, you know, my spindle won't go down in there. I suppose if I took this off, it would a little bit, but still, you know, not as versatile as I like it to be. Anyway, I'm just going to peel off the top of that boss and get it evened up. Well, I'm going to have to cut you off because my head pretty much has to be where the camera is in order to see what the fuck I'm doing. All right, I'm doing, last thing I got to do to this crankcase tonight, I use the oil pump mounting pad to level the case. I level the case so that the mill will mill off the weld I put on the drain plug boss and get it flat. I will tap it while it's in the mill so that the tapped hole is absolutely perpendicular to the case, to this milled surface I'm going to create over here. And this is, generally speaking, fairly simple. You guys have seen me do it before, I am sure. Yeah, and unlike Harley, who couldn't put the hole in the middle of the boss by eyeball, I'm going to have it closer to the middle of the boss than Harley did. That looks pretty good right there. And that pretty much concludes machining operations. I'm going to pull it inside, back in a clean shop, and take a look at what we did, what I did. Could say we did. We're going to pull it inside, take a look at what I did, and I got a couple other little things to take care of, but for the most part, this is done. So here's the final repair. Got the face of the thrust surface cleaned up, squared up. Got the bore for the shifter fork shaft straightened out. Got the broken out chunk fixed. All in all, I'm pretty happy with this. A little time consuming, a little tedious, but the owner wanted the work done, so I hope he's happy with this. And with that, I am out of here. We'll see you next time. Bye. Men, if you like this channel and this content, the single most important thing you could do to help grow this channel is to hit the subscribe button. I also have new design coffee cups and stickers available. You know, I like the old coffee cups, but I like these new ones even more. Links are included in the description down below. And for those of you who really want to go the extra mile, you could join me on Patreon. Link is also included in the description down below. And to all of you who have watched these videos, I'd like to say thank you. Thank you very much. I really, really do appreciate it. We'll see you next time. Bye.